Hello, I'm Ray, the Ray in the TheRayCode. In this video, I'll be studying the design pattern known as Builder. I'll be using Java. Now, I use other programming languages to study this design pattern. For example, I use C++, C#, and PHP. But for this video, I'll be using Java. Please check out those videos though. Now, for this video, I will give you a list of reasons of why a Java programmer would want to study the design pattern. I'll also go through the UML that was given by the game for in the book's Elements of Usable Code. Also, I go through a code example so you can play around with it yourself. I post the same code at my GitHub site and also at my TheRayCode. I'll provide a SWOT analysis for this design pattern. Now, I have put timestamps in the notes so you can navigate to the sections that interest you most. Please follow me on X, Facebook, LinkedIn. Leave a comment. Tell me what I'm doing right and also maybe what I'm doing wrong. Please subscribe. Give me a like. And also, this is most important, tell a friend. The Builder design pattern is a creational pattern that constructs complex objects step by step, separating the construction process from the object representation. Here are some reasons why a Java programmer should study the Builder design pattern. Simplify construction. Allows creating complex objects step by step without writing multiple constructors for different configurations. Readable code. Making object creation more readable and understandable by clearly defining construction steps in the code. Immutable objects. Facilitates the creation of immutable objects in Java, enhancing security and reducing unintended changes. Enhanced maintenance. Simplifies feature maintenance by isolating changes in object construction logic to the builder, reducing bugs. Design flexibility. Provides flexibility to change the internal representation of objects without affecting the client code. These reasons highlight the practical advantages of the Builder design pattern for Java developers in terms of code maintainability, readability, flexibility, and design. UML. Builder. Specifies an abstract interface for creating parts of a product object. Concrete Builder. Constructs and assembles parts of the product by implementing the Builder interface. Defines and keeps track of the representations it creates. Provides an interface for retrieving the product. Director. Constructs an object using the Builder interface. Product. Represents a complex object under construction. Concrete Builder builds the product internal representation and defines the process by which it is assembled. Includes classes, including interfaces that define the constituent parts into the final result. Collaborations. The client creates the director and configures it with the desired Builder object. Director notifies the builder whenever the product is built. The client retrieves the product from the builder. Hello, I'm Ray, the Ray in the TheRayCode. In this video, I'm planning to give you an example of the creational design pattern called Builder. I'll be using Java. I'll use the same names for the classes and methods that have been given by the game for in their book, Elements of Usable Software. We start with a class named Product. Product will be our complex object being built. We declare a private array list of strings to represent our parts. We need to import the Java array list and the list at the top. We create a method add to add parts to our product. And we have a show method to display our parts. We use print line to print our parts. We loop through the parts, and as we come to each part, we print it out. Now, let's work on the builder. Builder will be an interface. We'll require the user of this interface to have a build part A method. This handle will be an abstract. We will also require a build part B method, and we will get result to display the products. Now, let's work on the Concrete Builder. The Concrete Builder will implement the steps to build the product. This class implements the Builder interface. Because it implements the builder, we will require to have a build part A build part B, and a get result. We auto-generate the following code: build part A, build part B, and get result. For build part A, we add part A to the product. For build part B, we add part B to the product. And for get product, we return the product. Let's create the director class. The director defines the order of the building process. The construct method takes a builder object. So we have the builder build part A and build part B. So now let's go to the main method for our demo. We set up a director and a builder. We pass the builder object into the director construct method, and from the builder we get results. And we show. Let's compile and run. We get parts built, part A and part B. The builder builds complex objects in a step-by-step fashion. It separates the construction from the representation. Can be used with the same construction process to build different representations. My name is Ray. Always code with a smile. Here's our SWOT analysis of the Builder design pattern, creational in Java. S. Strength. Readable object construction. Builds objects step-by-step, improving code clarity, especially for objects with many optional fields. Avoids telescoping constructors. Replaces overloaded constructors with clear builder methods, enhancing maintainability. Encapsulates complex logic. Keeps complex creation logic within the builder, separating concerns and simplifying the main code. W. Weakness. More boilerplate code. Requires additional classes and methods, increasing the overall size of the code base. Can be overkill for simple objects. Adds unnecessary complexity when objects are simple and don't need step-by-step construction. Longer learning curve for beginners. New developers find the builder setup harder to grasp compared to constructors or factory methods. O. Opportunities. Enhances API designs. Helps create fluent APIs that are easy to understand and use, boosting developers' experience. Immutability. Supports creation of immutable objects, making code safer in multi-threaded environments. Improves testing and flexibility. Allows unit tests to easily configure test objects with specific combinations of parts. T. Threats. Misused by inexperienced developers. Builders used inconsistently or incorrectly can lead to unclear or buggy code. Possible runtime errors. If validation isn't handled well in the builder, it might create incomplete or invalid objects. Performance trade-offs. Can't add slight overhead compared to direct instantiation in performance-critical sections. Well, that was my video. Please give this video a like, leave a comment, follow me on X, Facebook, LinkedIn, or wherever you can find me. Even have a .com and a .org. But most of all, keep coding.